All right, hello class. Today I'm going to be talking about chapter 1 and the phone measurements as well. So, chapter 1 goes over a few different topics like physical quantities and units, accuracy, precision, and significant figures, as well as approximation and like physical quantity and units basically really what we're doing in the phone measurements. Like a physical quantity would be the amount of the units, and then the units would be the units. Like, for example, like I measured the width of my phone as 77 millimeters, so 77 would be the physical quantity, and then millimeters would be the units. Uh, that kind of, and then like accuracy, precision, uh, and significant figures, they all kind of go together. Like significant figures are important because you want accuracy and precision. Like, for example, if you're measuring something with like a ruler, you're measuring something with a ruler, and then you get you measure something to be like 6.5 inches, let's say, then it's like the importance of significant figures comes up when you try to use like a calculator to calculate the length. Like for example, with a calculator you might get like 6.592848 whatever. It can just keep going. But with the ruler, you really don't have that kind of accuracy. You kind of just have like 6.5, and then you do have small increments, but it doesn't really like get that long in the decimals. So yeah, that's kind of why significant figures are important. Like if you accurately calculate the measurement, you could probably get a long decimal number, but if like you're using a ruler, you don't want that kind of number. You just want to have the proper measurement that comes up on the ruler. That makes sense. And that kind of, I feel like that kind of ties in with approximation because, like, yeah, approximation, you kind of want to approximate like the length, like when you're using uncertainties, like for example, I'm gonna I'm gonna want to measure this box using my phone, and actually the the length of this box is actually exactly one of my phone. But when I measure this width, my phone goes up to about here. So this is actually about like plus minus half of my phone, which is like how you're using uncertainties to measure things. And I feel like that pretty much ties in with approximation, because yeah, you if you can't accurately measure it, you're just gonna have to approximate it with like an uncertainty using uncertainties. Uh, yeah, and so going on to the phone measurements. So yeah, like I said, I measured the width of my phone to be 77 millimeters and the length to be 157 millimeters. And for this diagonal, for the line across, yeah, I was able to find it by using the Pythagorean theorem. So the square root of 77 squared and 157 squared. And yeah, and I thought, or I thought I should say, in order to find this angle and this angle, you can use trigonometry in order to find it. So there's SO, CA, TOA. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and then tangent is opposite over adjacent. So in order to find this angle, what we can do is use sine, which is opposite over hypotenuse, this over this, and then inverse it. So basically arc sine of 157 over 174. But what we can also do is use this, or what we can also do is we can also do cosine, which is adjacent over hypotenuse, so 77 over 174. And yeah, the same applies to this angle as well. Like you can use sine or cosine. So yeah, I kind of have it just written down here. You can use, so these two on the top will equal the same angle as these two on the bottom. And yeah, we can actually just find that right now. I'll find the angle of this one first, which is basically sine inverse of 157 over 174.87. Yeah, I actually just went ahead and wrote down sine inverse of 157 over 174. So opposite over hypotenuse, and then this one I just decided to use cosine instead. So adjacent 157 over hypotenuse 174. And I thought I should just say really quickly like why I have decimal points in this, because I said in a ruler, like I use a ruler, and you don't really want decimal points in your ruler measurements, but the reason why I have decimal points is because I use the Pythagorean theorem of square root to find this value, because these values, I used the ruler, so I didn't really have any decimal points, but yeah, when I calculated with the square root, I got decimal points, and it's only 2, so I just decided to include it. So now this first one, sine inverse of 157 over 174, I'll do it right now. 157 over 174.87. And that gives us about 63.87. Yeah, that's a good estimate. And the next one is cosine. Which gives us about 26.13 degrees. No, my drawing isn't the best, but you know, the way I can tell this is correct, or estimate that it's correct, is like, although my drawing isn't the best, you see that this is 90 degrees, and this angle seems to be wider than this one. But another way I can tell it's like even more accurate is if I add 63.87 and 26.13. So if you add 0.13 to this one, it'll become 64 degrees plus 26. So add the 6 to 64, that becomes 70 degrees. 70 plus 20 degrees, 90 degrees. 90 degrees plus 90 degrees is 180 degrees. And a triangle has 180 degrees in total. And yeah, I mean, that's pretty much it. Yeah, I mean, I actually did use my phone, but that's what I'm using to record right now. But I did use my phone to measure my wall, and I got up to 20 phones in total, and then I had about a length that was less than my phone, maybe about half my phone left. And so yeah, because of uncertainties, I did plus minus one phone, and I can't really show that right now because, like I said, I'm recording with my phone. But yeah, uh, yeah, thanks for listening.